Okay, good morning. Let's discuss another topic today. The topic that we're going to discuss today is all about geometric mean of A and B of two positive integers or between two positive numbers. So there's a quick formula here that we're going to be using. We have x is equal to the square root of AB and alternative formulas, which is this one written in fraction form A over x is equal to x over B. And if we're gonna simplify this, we're gonna multiply a times b is ab, and then x times x is x squared. And then later, if we're gonna take the square root on both sides, we will have x is equal to the square root of ab. So simply, we use the formula x is equal to the square root of a times b. Now, for our objectives, we have to solve for the geometric mean between any two positive terms. And the geometric mean between any two positive terms of a geometric sequence is given by the square root of their product. You can also use the process of inserting arithmetic means between two terms in an arithmetic sequence, in inserting geometric means between two terms in a geometric sequence. So again, there are two ways to do that. One, to use the formula, and then the second one is by using arithmetic means between two terms in an arithmetic sequence in inserting geometric means. So how are we going to do that? We're going to be showing that in the next or succeeding slides. Okay, example number one, we have determine the positive geometric mean between 5 and 125. So what is that number between 5 and 125 in a geometric sequence? Okay, for our solution one, I will show first the first solution. Let us denote the geometric mean as x. We will represent the geometric mean as x. The number that we're looking for, the number in between 5 and 125 is going to be represented by x. So, by using the formula x is equal to the square root of ab, meaning to say the first number and the second number. So we have to multiply that and take the square root. So 5 times 125 and then the square root of that. Simplifying, we have 625, take the square root is 25. Therefore, our geometric mean or the number between 5 and 125 is 25. So that's how simply we find the geometric mean between two numbers, positive numbers. Okay. Alternative solution or the other way around to do that is like this. We're going to be using the arithmetic mean for inserting geometric mean in a geometric sequence. So we have a sub 1 is equal to 5, a sub 3 is equal to 125, and n is equal to 3. So sir, how did you get 5? How did you get 125? That's given. And how did you get n? So therefore, since we're looking for the term in between 5 and 125, there are three terms already. So 5 blank and then 125. So as you can see, we have three terms here involved. 1, 2, and 3. So we have three terms involved. So therefore, we're going to be using the formula for geometric sequence, and that is a sub n is equal to a sub 1 times ratio or the common ratio r raised to n minus 1. Okay, all that the information that we have, we will just plug that in the given formula. So since we have our a sub n or the last term here, as you can see, our last term is 125. So we just plug that into a sub n. That's our last term. So is equal to 125 is equal to 5 times r. Since we don't have yet the common ratio, but we have our n in the formula, n is 3 minus 1. And then after that, we divide both sides by 5. So that's why we have 125 divided by 5, it becomes 25. And then 5 divided by 5, 5 times 5 is 5. 5 times 5 is 25. 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 5 times 5 is we have r. If we simplify this one, we divide it by 5 as well. So therefore, we cancel that out, and then we simplify. 3 minus 1 becomes 2, and then r. Then next, we will be taking the square root on both sides. So taking the square root on both sides of this will now have 5. So our common ratio is 5. Therefore, if we look for the middle term or the mean, the geometric mean in this particular sequence, it's going to be 25. How? So since we know already the common ratio, we have our a sub 1, we're looking for a sub 2, the middle term. We will just multiply it by 5. So multiplying that by 5 gives us the answer of 25. Therefore, our geometric mean is 25. That's just the same with the first solution that we have. So this is just an alternative solution. We can always do this or the other way around, the first formula that I have shared a while ago. So let's have another example. So in the second example that we have insert a positive geometric mean between -3 and -108. So again, we will be using the first formula. Let us denote the geometric mean as x. And now we will just substitute that to the formula. Remember the formula that we have a while ago. X is equal to the square root of a times b. So our a is -3. Our b is -108, or the other way around. So you can write -108 times -3. That's just the same. You will have the same answer. Now, multiplying -3 and 108 gives us 324. And take the square root of that, we will have 18. Therefore, our geometric mean, or the number between -3 and -108, is positive 18. Okay, so that's the geometric mean of -3 and -108. Now, sir, what if there are numbers or 3 numbers that we're gonna look for in a sequence? So let's say example number 3, I will just write it here. Let's say look for the geometric mean between 2 and we have 3, or we're gonna insert 3 geometric mean. Let's say we insert 3 geometric means here between 2 and 2,592. Okay, so here we have our a sub 1, our a sub 2, our a sub 3, our a sub 4, and our a sub 5. There are 5 terms. Now, we can use the first formula, but how, sir? There are 3 terms already that you are looking for. So, between 2 and 2,592, we have a sub 3. That's the middle term of a sub 1 and a sub 5. So, we will use again the formula x is equal to the square root of AB. And then, since we will just multiply them, 2 times 2,592. Okay, we multiply that. And then multiplying 2 times 2,592 gives us 5,184. Square root of 5,184. So after that, taking the square root of 5,184 gives us the value of x, which is 72. So now, we have our middle term. Our middle term is 72. Our a sub 3. From there, you can now already solve. We can now solve for the geometric mean of a sub 1 and a sub 3. So, we will now solve for a sub 2. So, our a sub 2 is the geometric mean of a sub 1 and a sub 3. So, meaning to say, we're going to multiply 2 and 72. Okay. And after that, we take the square root of 2 times 72, that's 144. What's the square root of 144? The answer is 12. So that's the geometric mean between 2 and 72, or a sub 1 and a sub 3. So we can put it there. We can write 12. So therefore, our a sub 2 is 12. Now, sir, how about a sub 4? Of course, a sub 4, it's just the geometric mean of a sub 3 and a sub 5. So we will just multiply 72 times 2,592 and take the square root of that. So a sub 4 will be the product of 72 times, or the product of 72 and 2,592. And then we take the root. Okay, so multiplying 72 and 2,592, we can always have our calculator. So 72 times 2,592 gives us 186,624. 186,624. And then we take the square root of that, we take the root of that, gives us 432. So therefore, our geometric means are the following. So we have 12, 72, and 432. So that's how simply we solve for the geometric means of a given sequence. So as you can see, if we look for the common ratio, let's see if there is a common ratio in this geometric sequence that we have now: 2, 12, 72, 432, and 2,592. So check if we have a common ratio. Of course, we will just follow the formula. The formula that we have last time is that we use for finding the common ratio is S succeeding term over the previous term. So if we check 12 divided by 2, that's going to be 6. 72 divided by 12, that's going to be 6 as well. 432 divided by 72, that is 6 as well. And then 2,592 divided by 432, you will have the same answer, and that is 6. Now, if we look for the succeeding terms, you can now solve for that by just multiplying it by 6. Since that's the number that we multiply, or the pattern that we multiply in order for us to solve for the succeeding terms in the given sequence. So that's it. See you in the next video for the discussion of another topic in Math 10. God bless.